Hey, so let's get started with the second video. So in the previous video, you would have seen what is Git and how to get started with Git. So you would have installed Git on your system, you would have initialized a repository on your local system, you would have added some files to it, you would have staged those files, and you would have committed some changes to those files in that repository. But right now, all those files in your repositories are stored in your local system, in your computer. They are not uploaded anywhere. So let's say tomorrow your computer dies or something happens to your computer, or it maybe gets stolen, so all your code is gone. Also, let's say you have another friend who wants to work on the same code as you. So this is not allowed for the MID projects, but then let's say you're working on some other project where you're working with multiple people. So if the project is on your system, it's not possible for your friend to work on the project. So there needs to be a centralized place to store your code so that you and anyone else who's working on the project can conveniently access them and also update any changes they make. So that is where GitHub comes into place. So Git and GitHub are two totally separate things, but obviously very linked together. So Git is the actual technology that lets you do the version controlling. So remembering which file was edited when and what are the changes. GitHub is a website where we upload the Git repositories. So let's get started. So what is GitHub? GitHub is basically a website that allows you to store and share your code, right? So it's also a place where people collaborate with each other on projects. So let's start by creating a GitHub account. So most probably you don't have a GitHub account. If you do, you can just follow along to the next steps. But yeah, if you don't have a GitHub account, let's create a GitHub account first. So what you need to do is you have to go to this link, github.com, and this will open a page like this here. So first you have to do is you have to sign up. So if you don't have an account, you have to open this page and you will be asked your email account. So let's say you enter your email like 21F100, some college email ID which you have, the IIT email ID, let's say 001 or something. So after you do this, you have to press continue and then fill your password and all. So I will not do this because I already have an account. So what I'll do is I'll sign into that account. Alright, so as you can see, once you have signed in, you will be presented to a page like this. So this will be empty, you won't have any repositories here. So you will have a dashboard. So this is basically all the news that is happening in open source world. So what we really care about is our repositories, which will be visible in the leftmost pane. So before we can push our local repository into GitHub, what we have to do is we have to create and add SSH keys. So once we have created the account, what we have to do now is create a SSH key. So you don't have to worry what an SSH key is right now. This will be taught in details in the system commands course later. So we just have to create a key which lets GitHub understand that we are actually who we claim we are. So some random person should not be able to change your repositories, right? So code that is uploaded by you should only be able to be changed by you. So we create a key which is like a password. So it's not exactly the same as the GitHub password which you give while signing up, but this is a separate password. And what you basically do is you just type this command SSH keygen in either your Linux system, or if you are running Windows, then inside your WSL, Windows Subsystem for Linux, and this will just create the key for us. So we don't have to worry about how it's created. And once it's created, we just see the file which is stored there and we copy that file into GitHub. So let's open another terminal and let's type this SSH keygen. What this will do is it will create a private and public key pair and it will store it in your system. So it will ask you where to store it. So by default the location is set to your home directory and then .sh/file name. So you don't have to change anything, you can just simply press enter. And now it will ask you for a passphrase. So if your system is not shared by anyone, or you're just using this for the GitHub purposes, so you don't have to set a passphrase. If you want additional security, you can set a passphrase and then press enter, but otherwise you can just press enter directly, and then you can press enter again, and your SSH key is now created. So you can see a lot of output, you don't have to worry about it, just ignore it. So this will basically be saved here, /home/demo.ssh, and then this. So this will be your username. So this, for me, it's a demo right now. So what you have to do now is simply go to this, what you will have. So in this case, it is id_ed. For older systems, it will be id_rsa. So just look out what is present here in the output. So it will tell you where to go. So what you have to do is simply do cat ~/.ssh. And then if you press tab, you will get this name of the key. And don't press enter here because this is your private key. You have to do .pub and now press enter. So this is basically your public key. So now all you have to do is copy this, and usually in terminals you copy by pressing Ctrl plus Shift plus C. So once you've copied it, the next step is adding the key to GitHub. So open your GitHub and then open your settings page. So go to the settings here, and here we'll see an option for SSH and GPG keys. So just go here, and right now you can see there are no SSH keys. We can just click new SSH key and give it any title you want. So let's say demo key, and keep this as authentication itself, and then just press Ctrl plus V or paste, and your public key should be pasted here. So that's all you need to do for setting up your GitHub account. So now if you do anything from your system by doing Git, it will be automatically showing it here in your GitHub. So that's all you have to do to configure your GitHub, so that your system, whenever you do any changes and you want to push it to the GitHub, it can automatically authenticate you. So one more thing you have to do, and I think you have already done it in the first video, which is the configuration of Git. So after you install Git for the first time, so that's something you have to do only once, you have to do git config -- global. So you have to do it just once, and you basically make it global. So for every other repository, it will just take from this. You set your user.name and you give your name. So let's say demo account. And more importantly, you have to set git config -- global user.email, and here you have to set whichever email you have associated with this, right? So the GitHub account which you've created. So ideally it should be your IITM email ID. So something like 21f100 or something at ds.study.iitm.ac.in. Right, so for me it's something else, so I'll just set it real quick. And so now our Git is configured. So let's now create a Git repository in our local system and then push it into the GitHub. Okay, so now let's add the local repository into GitHub. So there are two ways to do this. One thing is you can start by creating the repository in GitHub by clicking this create new repository and then cloning that into your local system. Another way is we can first initialize the GitHub repository here locally and then push it to the newly created repository. So let us do the second one first, and then we will see cloning later. So hopefully you have already done this in the first video, but let's do it again just so that we have the practice. So let's create a folder here. Let's say Mad1 project. So now I've created a folder. So you can see in my home I have a Mad1 project folder. So I can just go into that Mad1 project folder, and now if you see, we are currently inside the Mad1 project folder. So it will be empty because we have just created the folder. And here we will add all our files and project files and all. So let's not worry about the technicalities right now. So let's set up the Git first. So to initialize the Git repository in this folder, what we have to do is we have to type git init and press enter. So you can see it's giving us some big warning. So we can ignore this at this point. So this is nothing but it's telling that it has initialized the repository, and it has also set the default branch. So what are branches? We will learn this later. So it's not important right now. But you can think of branches like multiple copies of your code, right? So the default copy's name is master, and right now Git is telling us that it has been using the name master for all these years, and it has still created your project with the master as the branch. But then some websites like GitHub will tell you to name it differently as main for cultural inclusivity reasons. So it's telling that if you don't want this warning, you can just do this. So let us do this, and git config global init default branch, and let us set it to master itself just to maintain the same. Alright, so now if I, let's say, remove, so you don't have to do this, but I'll just demonstrate. So if I remove the Git folder which is created now, and if I do again git init, so you can see now we don't get the error message anymore, or the warning message. So this just says the initialized empty Git repository in our folder. So as you can see, it says .git, right? So this is the name of the folder which we are in. So inside our home directory, this is the Mad1 project, is our project name, and .git is basically a hidden folder where Git stores all the things it needs, right? So while doing a project, we will need some files, and like some Python files and some other files. Git also needs some files to track our changes, right? So all those files are stored in the .git. So if you do ls, you won't be able to see it because it starts with a dot, so it's hidden. So we can just do ls.-a, and we can see, okay, so .git is actually a folder which is present in this folder. So you don't actually have to worry about anything inside, but just for curiosity, let's see what's there inside. So there are multiple folders. So this folder maintains the branches. This is for the config and all. So all these are stored inside the .git folder. So right now we have the git, and as you know, we can type git status to see the status. So right now we don't have anything, any file or any commits yet. So let's create a file. Let's say usually the first thing created in our repository is a readme file. So you can either, if you're on Windows, you can open Notepad here and create a readme file, or you can open VS Code. So let's say you can do code dot, so it will open VS Code in this location. So you can see VS Code opens in this repository, and it's asking, do we trust the folder? We say yes, and then we have not set anything up in VS Code, so it's giving us some recommendations. So you can set the themes, you can set a light theme, you can set a dark theme anyway. So now the project is opened in VS Code, so you can usually just use VS Code for everything, but then we will also see how to do things in the terminal itself. So let's create a file named readme.md, and usually by convention the readme word is capital, and here we can simply just add some simple text that so you can save the file, and you can see if there are changes, it will show as a white dot here, and as soon as you press save, it will go away. So make sure whenever you're running your project, you have first saved your files. Alright, so once your files are saved, you can see that the file is created here, and if you do git status now, you can see that there is an untracked file. So Git is asking, okay, this is a file I have never seen before in this repository. This is totally brand new, and I don't know what you want me to do. So do you want me to actually track? So by track, it means that I will see whenever the file is changed and something. So if some lines in the file is changed, if the file is deleted, etc., it will track it. So right now it's not tracked, and usually readme is something we do want to track. So what we will do is we will do git add readme. So what this will do is this will add the readme.md file in the list of the files which Git will be tracking for this repository. So we can also directly do git add dot. What dot means is basically the current directory. So if we do git add dot, this basically means anything new that's inside the directory, track that as well. So now if you do git status, you can see that it's instead of red, it's now green. That means that, okay, so now I'm tracking this file, and this file has also been changed. So there's a new file which is readme.md, which we just created. So if you by mistake added it, you can just do this git rm cached and then the file's name. So this will again basically, so it says rm, but then it didn't delete the file, so the file is still there, but it's basically no longer tracked, so it is again untracked. So we can again basically just do git add readme.md, and you can see that it's now tracked. So it's telling that these are the changes that is now going to be committed. So this is some change you have made. So now we simply do git commit. So one easy way to do it is simply just give -m and type the message here itself. So you can just say added readme or add readme file, and you can press enter. So your commit will be done. So let us now make some changes to the readme, and yeah, any change is fine. So now you can see if I do git status, it is now telling me that the file is modified. So we have already added the file into tracking, and now we had also committed a change to it. But now that we have made some other change, so Git is now telling, okay, now the file is now modified. So what do you want me to do? So we simply say again git add, and what this does is this again add, like pushes this file into the staging. So staging means that now I'm going to commit this as another commit. So another way to commit, so one way we saw is using the -m, and we can directly put the message here, and I would recommend for people starting out to just use this one, because it is much simpler. You can just type whatever you want, just don't forget to give the quotations. So because if you have multiple words with spaces, you need the quotations, otherwise it will not work. But another way is you can just type git commit and press enter, and what this will do is it will open a temporary file where you can type your commit message. So this is basically the same as the -m, but sometimes it may open in some terminal text editor which you don't know how to use or how to get out of. So like in this case, this is opening in Vim or VI. So just know that how to do simple things in here. So if it opens nano, then it's fine. You can just see in the bottom how to exit. But then if you are in Vim, you can just press escape and then press colon. As you can see, I've pressed colon, so it's visible here. And then you can press Q exclamation. So I've come out, and we didn't write anything there, right? So usually what happens is you have to write something here, and then whatever you write will become the commit message. But because we don't know how to use Vim, we will do colon Q exclamation, and because it was empty, so it did not make the commit, aborting commit due to empty message. So we can simply do using the -m here, so modify readme. So you can do it like this, or if you want you can use the git commit also. So if you know how to use Vim, you can just go into insert mode and write the message here. And once you have exited now, because we saved the file and we exited, it will say the one file changed, one file inserted, one file deleted. So this is basically the change done in readme, and this commit message is also saved. So right now what we're doing is everything we are doing is stored in our local system. So if you do git log, you can see, alright, so I have this commit which we made earlier and this commit which we made now, and this is the latest one. So this is the head. So head basically means that the latest commit, where so if we make some other commit, that commit will go on top of this. So it's like a stack, it will keep on building on top of it. And master is the name of the branch we are working on. But as you can see in our GitHub, we do not have this mad1 project, right? So ignore these two, these I added earlier, but then we don't have that repository. So what we have to do is we have to first create a new repository here. So usually we keep the same name, but you can keep a different name also. So let's just take the same name, and I will name it mad1 project. And now here is an important decision you have to make, whether the project will be public or private. So if it is public, anyone on the internet can search and see your code and everything in your code. So for your mad1 and mad2 project, you should keep it private only, you should not keep it public. So click on the private here, and don't click anything here. So don't add git ignore, don't so this will cause problems if you are adding. So, and don't click this add readme, because we already have a readme here, right? So you may be tempted to check this, but then no, we will be pushing our files from our system to the repository. So we don't want to initialize the repository with some default files. We want it to be empty, and then we will push it. So now we press create repository. So as you can see, the changes we have made, you can see them using the git log, and we have added 2 commits, but they're in our local system. So head means it's basically the last commit, and any other commit we make will be on top of this commit, and master is the name of the branch. So right now this is in our local system, and we created this repository with the same name, mad1 project, but then there's nothing here. So if you refresh also, you don't see the code here. So this is because we have not linked this URL with this repo. So Git has no way of knowing that, okay, you created a repository here, right? Because Git can be hosted on GitHub, it can also be hosted on things like Bitbucket or GitLab. So these are also another websites like GitHub, so you can use any of them. So we have to basically let Git know in this folder that, okay, any changes I make, and if I tell you to push it to this link. So what we will do is, first of all, remember that we had created a SSH key. So we will come here and we'll click on SSH. So now this will make our life easier. Now you don't have to worry about so much which is written here. We have already done this. So this is basically telling us to initialize the repo and then add some file and then commit it. And don't have to worry about this line, because this is just basically renaming the default branch, right? So our branch is master, and it's asking us to rename it to main, but we don't care about all that. So we'll just copy this line, which is the remote. So what this line means is, git is the name of the command, and remote is something which means the URL of the cloud server, right? So GitHub is basically one cloud provider which hosts your Git. So we just add this link here to the Git. So remote is the subcommand to do this. So git remote add. So what we are doing with the remote, we are adding a new remote. Now origin is just a name for the remote. So just like you add your friend's number in your phone, so it may be a like 10-digit long number, and you don't remember your friend's number always when you want to call him. So what you do is, whenever he gets a new number, you just save it in your phone once and give his name. So let's say your friend's name is Jack or something. So you just give the name and you save it, and whenever later you want to call him, you just type Jack and you press dial. So you don't have to remember the link, so the phone number. Similarly, if you don't have to remember the link, you just save it with the name. So usually the term origin is always used for your own repositories, but it can be anything. So you can, let's say, type GitHub or my repo, something like that. But let's stick with the norms right now. So this will be origin. So git remote add origin, and then this thing which basically we copied from here. So this is the link of the repository. So when we do this, now Git knows that whenever I tell him to push something from this local folder into the cloud, it should go to this link. Alright, so now you can see the last line is git push. So here it's main, but for us it will be master. So what we do is git push -u origin master. So what this means is whatever commits we have, right? So we have 2 commits right now, this commit and then this commit. So all the history of this commit, all the snapshots of your code, just push it to this repository. So I have already saved the repository with the name origin, so just refer to that name and in that name, in the branch master, because our branch is master, just push this code. And the -u simply means that, okay, remember that this is my default. So when I tell you to, let's say, pull, get pull, don't ask me, okay, which origin, which branch, nothing. Just this is the default branch and this is the default remote. So this basically means set as default. So if we press enter now, and because we had set the SSH keys, right, so usually it will be by default set in HTTPS, and then it will ask us for username and password. But because we have done once of setting the SSH keys, it will not ask us anything else. So the first time you're using the SSH keys, it will ask you, are you sure you want to continue and you want to connect to GitHub? So the first time you have to do yes, and after this it will not ask you anymore. So now you can see it has pushed it. So all this means is it has been pushed. So now if you refresh this page, you can see the project is here, and whatever we added, demo repository is now there. So these are the steps we took to upload the code. So first we created the repository and we set it to private, and we did not check any other initialize, and then we clicked create. And then we already had some changes in our folder, so we added them and committed them. So we opened the folder, we went to the directory, which is this Mad1 project, and then we git initted it, then we created some files and added it, then we made some commits. So we have done it multiple times, we have done add and commit 2 times. Then we do this once, so we need to do this only once after creating the new repository, and not every time. So we do git remote add origin and then the SSH URL, and then we do git push origin master. So these 3 lines, add, commit and push, this is something we will be using at least 1,000 times. So every time you make some change, like say one module you have added or fixed some bug, you add those files to the staging, you commit that with a meaningful message, and finally you push it. So this remote is just you do it one time, and it is also something you do it one time. Add, commit and push is something you do every time. So what are remotes? Remotes are basically references to the repositories, right? So the repository in your local system is just a folder, but then it is also stored in GitHub using a certain unique link. So that link is simply your remote, and it's common to have the remote named origin, but then you can name it anything in your Git. And it can also be hosted on other websites like GitHub, so namely GitLab, Bitbucket, and there are others also. So now let's look at what are forking and cloning. So let's do this process of basically 3 things, right? So add, commit and push. So init and then remote add is something you do it only once, but add, commit and push is something you will do many times. So whenever you are adding some module or fixing some bugs, or let's say something you have done, and then you want to make sure that changes are saved. So these 3 things you will do: git add, git commit, git push. So let's keep on doing it multiple times, and I'll urge you to also follow along so that you also build your muscle memory, because at the end it's nothing but practice. So we have created the readme file. Now let's create some other dummy file. So let's say I want to add the Python file, so I'll create a new file. So you can just use code here, so you can do code dot and it will open your VS Code here, or you can use some other text editor like Vim. So let's just use VS Code here right now, and let's create a file called main.py. So let's say you name it main.py or app.py or run.py, anything. So I've created a file, and then let's say we do something here, hello world, and I make some spelling mistake. When I save it and I think, okay, it's perfect, it's working fine, and I didn't test my code and all, so I'm like, okay, I'm happy with this. So if I do git status, I can see that, okay, there's a new file. So I'll do git add main.py, and I'll now git commit. So let me say added main.py file, and my commit is done. And then let's say I push it also. So I'll do git push origin, git push -u origin master. So one shortcut you can use to make your life a little easy is let's say you can say alias gpom or something like that to git push -u origin master. So this is optional, you don't have to do this, but then if you do, this will basically mean that you can just type this instead of all this. So I can just type gpom and it will do the pushing part. And let's wait for it to push. Yeah, it's now done. And then you can see, if you refresh now, instead of modify readme, it will say added main.py, and you can see that, okay, there's something wrong. So let's talk about issues now. So as you can see, there's a issues tab here. Other tabs are also there. So let's click on issues. Let's see what issues are. So it's basically described here, right? So issues are used to track to-dos or bugs or feature requests and more. So issue is basically you can say like a front desk. someone comes and tells you, hey, your code is not correct, something is wrong. And it does not have to be someone from outside also, it can be you as well. So you can create an issue to just, let's say, remind you, okay, this is something that is left for me to do. So let's just create a new issue, and let's say I'm someone else, or let's say I'm the same person. I say typo in main.py. So, and issue is something where no code is added, it's just a place to tell you what's wrong but not how to fix it. So let's say I say in file this pen. Alright, so that's usually enough, and then we can some repositories will have bigger things you have to write, so how to reproduce, etc. So you can say open the file. So you can submit the issue, and now the issue is there. So let's say now you're the one of the contributors to the repository. So let's say you or your friend sees the issue, so they will open the repository and they'll see, okay, there's one open issue here, and they'll say, okay, so this is one open issue, and they say that there's a typo in main and the word world is misspelled. So you can just go to this file and you can see, yeah, it's wrong, right? So what you can do is you can come here and you can now obviously open the code and you can fix it. So yeah, that's all, you have fixed the issue. But now you have to push it to the repository, right? So right now the Git status is the main is modified. So let's add main.py again. Let's do git commit -m fix typo in main.py and git push origin master -u. So now this fixed version of main.py will be pushed to this page. So as you can see, it is now fixed. So fixed typo in main.py, and this is also now here fixed. But now you can see the issue is still remaining, right? So this is still there. So one way to close this is you can, let's say, if you are the maintainer itself, you can come here and say fixed in some commit. Or another thing you can do is you can go to the commit and you can say fixes 1. So you can see if you open the issue, there's a number here, right? So #1. So this is basically the number of the issue. So because it was the first issue, there's only one issue here. So this is issue number 1. So you can just go to the commit which fixes the issue, and you can just write a comment here that fixes #1, which is, and GitHub is smart enough, so it will tell, do you mean this one? Yes, yeah, this one, and you comment this one. So now if you open this issue, you will see that okay, so this issue was referenced somewhere, and if someone else was seeing this issue, they will understand, okay, this is fixed somewhere. And just so that you can make sure that this is actually closed, you can this one close as completed, that this was true and then I have actually fixed this, so you can close this. So now the issue is closed, and from open this becomes closed. So now if someone comes to the code or to the issues, they will see no issues. So that issue is still there, but then it's closed. So only if they go and close, they'll see, okay, this issue used to be there, but then it was fixed by this commit. And now as you can see here, something you basically have to come and comment here. But if you want to directly make this fix, one thing you can do is you can type that fixes in directly in the commit message itself. So we'll see how to do that next. So let's say I want to nitpick some other mistake, right? So I'll say, okay, get is fine, you can type in smaller case, but GitHub usually G and H should be capital. So let me go and create another issue, and let me create a new one and say GitHub should have and uncapitalized definition, and I create the issue. So now what we can do, you can see that the issue number is #2. So now we come here, we go to readme, and we just make the appropriate changes. So I make it G and I make it H, and similarly I make it G and I make it H, and I save it, and then obviously the same thing. So let's keep on doing this so that we have the habit or the muscle memory of this. So git add file, git commit, and now instead of doing -m, I want to open the commit here because I want to show you how to directly add the fixes here. So in commit message there are two parts. So the first is the first line, which is the title of the commit message. So here I can say, let's say, change GitHub to GitHub in readme. And if you now press enter and type something, you will see that usually it's red in color. It depends on your editor if they are doing this for you or not, but basically this means that this second line should always be empty. You're not supposed to write anything in it. So if you give one empty line, so the first line is now the title of the commit, and the line after this here is the description of the commit, and here you can say fixes #2, and you can just save and exit. So you can see now the same commit, okay, it is done. So the commit is done, and if you go to git log, you can see, okay, this commit which is changes Git to GitHub is done, and then also this commit description is there, and you can see that this is the origin, which is the GitHub, and this is how where our local state of the project is. So that we can push this here, we simply have to do git push origin master. And also when you're in git log and you want to exit this, you can just type q here. All right, so let's just do git push origin master because we've already made the commit. And you can see the commit is pushed, and automatically you can see we didn't have to click on close, or we didn't have to type anything here. It is automatically closed by GitHub. So GitHub is smart enough to understand, okay, in this commit message, in the description itself, we wrote fixes #2. So it means, okay, so this commit itself is fixing #2. So it will directly go to #2 and it will mark it as closed. So obviously you can come and reopen it if you think it's a mistake, but then this is something that GitHub does for you automatically. So yeah, now the issues is gone. So that is a simple example of what issues are and how committing works. And there are obviously a lot of details going on in here which you can learn on your own later. But for this project, this much information is enough.